So here we have question 8, which is the first question for section 2. So we have, for part A, in the diagram on page 25, so that will be this diagram here, it shows 6 points of the function y is equal to 3x plus 1 over x. So let's see. Point number 1, 2, 3, 4, 5, 6. Now they're saying that the coordinates of these 6 points are given in table below. So we have the x part of the coordinates on top here, and we have the y part of the coordinates below here. Now we can clearly see that here is missing and here is missing. So for part 1, they want us to complete the table above by calculating and inserting the missing values of y, which just means to fill out these two values that are missing here. So we want to know what is y when x is 0.5 and what is y when x is 2. So we have our function here, y is equal to 3x plus 1 over x. So I'll simply put when x is 0.5. Alright, we're going to have y is, our function is 3x plus 1 over x. So that simply means replacing the x in our function with 0.5. So we're going to have y is equal to 3 times 0.5, 0.5 plus 1 over 0.5. Now we can work this whole thing out on the calculator. So let's bring the calculator up. Alright, so I'll type the information exactly how I see it there. So I'll put 3 open brackets, put the 0.5, 0.5, close the brackets. Then I'll put plus, and for the 1 over 0.5, we could use the fraction button, or we could do open brackets 1 divided by 0.5. So I'll do it both ways. So you could open brackets like this, and put 1 divided by 0.5, and close brackets, and press equal, and we get 3.5 as the answer. Let's do it with the fraction button now. So press 3, open brackets, 0.5, close brackets, plus 1 over, so there's a fraction button here, so press this for over 0.5 and press equal, and you see we still get 3.5. So for here, I'm putting 3.5. Now I'll work out for when x is equal to 2. So I'll have when x is equal to 2, our function still is 3x plus 1 over x. So we have y is equal to 3 times x, which is 2, plus 1 over 2. So y is equal to, forget to put the answer here, so y is equal to 3.5. And again, I'll use the calculator, so let's clear this off. So 3 open brackets, 2 close brackets, so that's the 3 multiplied by 2, plus, and for the half, I'll use the fraction button, so 1 over 2. Press equal, we get 6.5. Now I'm plotting points, so yes, I know 6.5 is 6.5. So if I wanted to convert the 6.5, which is a mixed number, to include the decimal, I'll just have to press the fraction button again. See, and it's into 6.5. And of course, I'll prefer the 6.5 because I'm looking at the table and, they didn't put any fractions on the table. They didn't use decimals. So I will use the decimal form, which is 6.5. Alright, so let's put the 6.5 here as well. So now I have completed the table. So now for part 2 of the question, we have on the diagram on page 25, which is this diagram talking about again. The ordered pairs shown in the table have been plotted, except for the missing ones. So use your answers in A part 1, right? Plot the missing points and connect all the points with a smooth curve. So we have 6 points here already. And we want to use our answers that we worked out in A part 1 to fill in the table. So that's the 3.5 with the 0.5. When x is 0.5, we know y is 3.5. And when x is 2, y is 6.5. So now looking at the x-axis, we have 1, 2, 3, 4, 5. 5 blocks. And now we want to plot where is 0.5 on the x-axis. So obviously half of 5 is 2.5. So 2.5 blocks will represent 0.5. That's 2.5 of the 1 centimeter blocks. So 0.5 will be in the middle right here. And now we're going to map that to 3.5 on the y-axis. So 3.5 on the y-axis, this is 3 here, this is 4. We have 2 blocks. We have 2 blocks separating 3 and 4. Therefore, 3.5 is right here in the middle. So we come in here with 3.5 and line that up with 0.5 on the x. So 0.5 on the x is 2.5 blocks. 1, 2. 1.5 right here, go all the way up to 3.5, which is right here. And that's our point. Next, we'll map 2 on the x with 6.5 on the y. So that's simple for the x. The 2 is right here, you can see that. But the 6.5 will be between 6 and 7. So that will be in the middle right here. So we can just come across on 6.5. We can see the 2 clearly. Going to line up here with 2. I'm going to plot that point right here. So now that we have our 2 points plotted, it's time to make a smooth curve to connect all these points. Alright, not the best, but it's a freehand curve to try to connect all these points with a smooth curve. So this will be a graph here. Now coming down to part 3 here, they say by drawing an appropriate straight line on the diagram on page 25, so that's this diagram again, find approximate solutions to the equation 3x plus 1 over x is equal to 6. So now the way we're going to look at this is that we're going to have two graphs. One graph is going to be y is equal to 3x plus 1 over x, and that'll be our first equation. And the other graph is going to be y is equal to 6. And that'll be our second equation. So now we already have the graph for this equation 1. This is what we drew here. And if we draw the graph for y is equal to 6, the point of intersection or the points of intersection between these two graphs will be the solution to this equation. So y is equal to 6, we're going to find 6 on the y-axis and draw a horizontal line across. So I'm doing that now, making the straight line across. And this will be line y is equal to 6. And of course, this graph here is y is equal to 3x plus 1 over x. And these two graphs, they intersect here and here. So I have a point of intersection here and a point of intersection right here. Now remember, this was a freehand drawing, so of course the answers will be an approximation. So we have 2 points of intersection. So how does that help us solve the equation? Now remember, this is the equation here. So we want to solve for the value or values of x for this equation. So this point of intersection would have a x part of the coordinate and a y part of the coordinate. Now obviously the y part of the coordinate is 6 for both points of intersection. So what we want is the x part of the coordinate for both of them. And that will be your answers for this equation. Now, in order to do that, you can see where this is located. I'll need to know what each little block representing to be able to read off the x part of the coordinate for here. So now if we look down here on the x-axis, we have from 0 to 1, that's 1 unit. And each 1 centimeter block has 5 little blocks. And we have 1, 2, 3, 4, 5. 5 1 centimeter blocks in total. And each of them have 5 little blocks. So that'll be 5 by 5, which is 25 little blocks. Which means for the x-axis, one of the smallest blocks will be representing 1 as the 1 unit over the 25 little blocks. So that's 1 over 25. So I'm just going to write here for the x-axis, one of the smallest blocks is equal to 1 over 25. So the 1 is because the x-axis, the unit is 1, mean we counting in ones, right? 0 to 1, that's 1. 1 to 2, that's the next one. You know, we're going up by 1. So 1 unit. That's why here's 1. And the space between that 1 unit is 25 little blocks. And that's why we're at 25 here. So if I get my calculator and I put 1 divided by 25 on my calculator, I'll get 0.04. So that means one of the smallest blocks is 0.04, and that's for the x-axis. So I'm going to have this is equal to 0.04. So let's look at something here. This space in here, we have 1, 2, 3, 4. We have 4 little blocks. All right. So 4 little blocks is going to be this 0.04 multiplied by 4. All right. So my answer's going to be x is equal to, and I'll go on my calculator and I'll put 4 multiplied by 0.04. And I'll get 0.16. So I'll write 0.16. That's my first answer. And now for a second answer, we come to this point of intersection. So it looks like this point is directly on this line. So if you come all the way down, we see in the x value will be here. So if we look, this is 1, 2, 3, 4 1 centimeter blocks away from 1. So now we know that each of the 1 centimeter blocks have 5 little blocks. And we have 1, 2, 3, 4 of them to reach this point. So 4 by 5 of the little blocks, right? Will be 20 little blocks away from 1. So we just have to multiply that 20 by 0.04, and we find out how far away from 1, this point here is. Okay? So we just multiply 20 by 0.04, and we find out how far away from 1 this point here is. So if you go to the calculator and multiply 0.04 by 20, we get 0.8, and that's how far away from 1 the point is, right? So we'll have 1.8. That would this point go be 1.8. And our second answer will be x is equal to 1.8. And those will be answers for this question. Let's put x is equal to 0.16 or x is equal to 1.8. So moving on to part B of this question, we have the speed time graph below shows the information on the first 60 seconds of a car's journey. So that's the graph. We have time below here, so from 0 to 60, that's the car's journey. So here we have the speed in meters per second, so that means the distance is in meters, and of course the time is in seconds. Now part 1 of the question, they want us to calculate the acceleration in meters per second squared of the car during stage B. So this is stage B here. And as we know, for a speed time graph, the gradient of the line would give acceleration. So we want the gradient between this point and this point, which would be stage B, and that would be equal to the acceleration. So I'll just form this triangle here. So now we know this distance here will be the change in y, which is a vertical distance, and this here horizontal will be the change in x. So for the vertical distance, we start here and we go across. We have from, well, here will be 15, because here's 10, here's 20, and here's in the middle. So the difference between 10 and 20 is 10, and half of that is 5. So 10 plus 5, 15. And then we're going all the way up to here, which is 40. So I'm going to put my change in y is equal to 40 take away 15. And 40 take away 15 is 25. So that's my change in y. So I can write here the change in y is equal to 25. Now let's look at our horizontal distance. We have from 40, as you can see here, to 60. So we just have to take away 60 from 40, and we get our change in x. So our change in x is equal to 60 take away 40, and that would be 20. So here our change in x is 20. Now, some points to notice that as we go from left to right, the line is going upwards, which means the gradient is positive. If the line was going downwards, as we go from left to right, the gradient will be negative. So now my gradient m is equal to a change in y over the change in x. So gradient is equal, the change in y is 25 over a change in x, which is 20. We work that out on the calculator. All right, so we have 25 divided by 20, and we will get 1.25. So that's 1.25 as our gradient. And of course, we are saying that the gradient is equal to acceleration. So my acceleration, A, is equal to 1.25 meters per second squared. So now for part 2 of this question, they want us to calculate the average speed of the car during stage B. So this is stage B here. Now you know average speed will be the total distance over time taken. Now the time taken is easy because we can read off, we stop at 60 seconds and stage B started at 40 seconds, right? So the difference between 40 and 60 is 20. So your time taken is 20 seconds. Okay, so I can write out that's the easiest one. All right, for stage B. All right. Time taken is the difference between 60 seconds and 40 seconds. So that's 20 seconds. So now the question is, what is the distance for stage B? Now we know the area under the graph represents distance for a speed time graph. So let's like to mark off stage B. We have here. We have here. All right, so you can see I blocked off stage B and we can see the area under this line. Now this shape is a trapezium. All right, so let's get the dimensions of the sides of the trapezium. Now it's obvious that this side here is the 20 seconds, so that has to be 20. All right, so down here we have 20. The length of this side would be all the way up to 40. So this is 40. Now the length of this side here would have been 15. So this is 15. Now remember, I'm looking across here, right? This is 15 here, so the length of this side is 15. Don't worry about the units. All right, from 0 to all the way up here is 40, so the length of this side is 40. And of course, from 40 to 60, this is 20, so the length of this side here is 20. Now, I don't need the length of this side. We know the area of a trapezium is a half the sum of the two parallel sides, so that would be the 15 and the 40, multiplied by the height, which will be the distance that's perpendicular to the two parallel sides. So the height is going to be 20. If you want, I could put these arrows here to identify the parallel sides. And of course, this is your right angle here. So I'm going to go area of trapezium is equal to half the sum of the two parallel sides, which is 15 plus 40, multiplied by the height, which is that 20. The distance that's perpendicular to the two parallel sides. Now, obviously, 15 plus 40, that's 55. All right, times 20. All right, so a half times 55 times 20. All right, so working that out, I mean, you can put 0.5 for a half or use the fraction button. So 1 over 2, that's a half, multiplied by 55, multiplied by 20, and we get 550. All right, so we have 550. Don't worry about the units. Now, the thing is, the area of the trapezium, which is the area under this line for stage B, is the total distance for stage B. So we're going to have total distance is equal to 550. And now we said the distance was in meters, right? Because our speed was in meters per second. So distance in meters times in seconds. So now we have the total distance for stage B and the time taken. So speed is, well, average speed is the total distance over the time taken. So average speed is equal to my total distance over time taken. And that's equal to my total distance, 550, over the time taken, which is 20. All right, so working that out, we have 550 divided by 20, and we'll get 27.5. Okay, so that's our average speed. Of course, that'll be meters per second. All right, so that's equal to 27.5 meters per second. Now, for part 3 of this question, we have at time t is 60 seconds, the car starts to slow down with uniform deceleration of 2.5 meters per second squared. Now, remember we said that acceleration was the gradient of the line. So the acceleration for stage A will be the gradient of this line for stage A. The acceleration for stage B was the gradient of this line for stage B. Now, the thing about both stage A and stage B is that these lines have a positive gradient, and that's why it's acceleration. Now, deceleration would have a negative gradient. So, still working on gradient. Deceleration is just negative acceleration. So, negative gradient, deceleration. All right. So, that means from this point, we will come all the way down to 0. Now, for a time, I would not know, where to bring this line down. But for the speed, I know we are starting at 40 and we need to go all the way down to 0. From 40 all the way down to 0 to come to rest. Rest means the speed is 0 meters per second. So essentially what we have here is that the gradient m is equal to negative 2.5 all right, because that's what the deceleration could be, gradient. We'll have our change in y over our change in x being our gradient, which is negative 2.5. And the change in y would be from 40 to 0, all right? Now, usually when we have a negative gradient, we represent the change in y as negative. So I represent that as negative 40. So we have negative 40 over the change in x is equal to negative 2.5. So if you want to get rid of the negative signs, you could do that, because if here's negative and here's negative, then 40 over the change in x is just 2.5. So with that out of the way, what we want to know is the change in x, which is the horizontal distance, which will give us, the time it takes to decelerate. So we can do some simple cross multiplication here. We can just put the 40 over the change in x is equal to 2.5 over 1. We multiply change in x by 2.5. So we have 2.5 times the change in x. And you multiply the 40 by 1. And that will be equal to 40. So now my change in x is equal to 40 divided by 2.5. So my change in x is equal to, all right, so that's going to work that out on the calculator. 40 divided by 2.5, and we get 16. So that's 16 seconds. All right, so that's 16, my change in x, seconds. All right, so the car comes to rest in 16 seconds. And this will bring us to the end of this video.